Welcome to Bright School, home of Rwanda's first STELA Future Hopes LEGO Robotics team. Thanks for joining us here in Muhanga at a regular team meeting. I'm Bill Whipple, a Teach Rwanda board member and coordinator of the program. Teach Rwanda operates Bright School, a nonprofit preschool and primary, as a demonstration program. We mentor teachers and now also robotics coaches to encourage students' curiosity and creativity, as well as develop their executive function skills.
Hi, I'm Eric Biribus, an engineer at Corning Incorporated in New York in the US. I'm also a Teach Rwanda board member. Bright School's LEGO Robotics team is supported by STELA, Science, Technology, Entrepreneurship, Leadership Academy, a nonprofit which I founded. Our goal is to bring world-class education to students in underserved communities. Students on robotics teams implement decision-making, technology, engineering, and teamwork, which are so important for their future success. With robotics, every child can be a winner in school, work, and in life.
Please join some of our Rwandan robotics team members, 3 volunteer coaches, and an intern from Africa Leadership University. We want you to see the knowledge, skills, and dispositions that students can gain when they design, construct, and program robots.
Hi, my name is Eunice and I'm in P6. My friends and I waited for 2 long years during the COVID time before our robotics team could start. One team meets on Saturday and another on Sunday.
I'm Junior, also in P6. In this video, we are going to explain what we are learning about how to create and programming robots, and show you how we work together to accomplish our goals. I want to be a computer programmer, so this is the beginning of my career.
Visha is my name. I'm in P6 too. Most of us on the team have been playing with Lego pieces since preschool, but Lego Spike have many interesting parts, which may be sensitive touch, light, and even rotation.
Can you figure out what is this? It's a motor. And this is the hub which we connect the all parts.
Students program these hubs to control their robots' actions.
I'm Consolé, a student in P6. How do we use this thousands of parts to make a robot? For example, to pick up blocks, spin the always wheel, or throw a part. We will show you how our processes work.
It's the same analytical process that scientists, architects, doctors, and engineers use to solve problems every day. Consolé is going to be a doctor of midwifery, so she will certainly have challenges to figure out in her career too.
My name is Philemon. When these Bright School students were first beginning to learn about programming and robotics, we coaches gave them a simple problem to solve, either to put together an original robot or program their robot to do a specific task.
Now we have figured out how robots work, so our team decides on our goal, which is usually really creative. Our team captain leads the way. What do we want our robot to do? We define the problem we want to solve.
I'm David, a new coach. Today, our team is working in 2 groups. Each group has a different challenge. Some team members will build a machine or a vehicle that can unload cargo from this train on the cargo to connect challenge map.
The other group will create a working drawbridge over this imaginary river with an island. Both robots will demonstrate their solutions on the mat.
Our teams use an engineering design process. First, we research relevant information about our challenge. We want to make informed decisions for our robot's design based on physics, math, and programming. We gain new computer skills and discover exciting ideas every time we do research.
I'm Alphonsine, a P1 teacher at Bright School and a new coach too. Our robotics team members think of possible solutions based on their research. Students propose ideas and compare them. Teachers use these same student-centered and project-based teaching strategies in every classroom at Bright School.
Everyone shares their ideas after a lively discussion on the option. Our team selects the most promising solution. Here is what we decided today.
First, we studied the cargo plane to see how the cargo door opens. We decided that our robot needed a knob to pull the door down. We drew ideas for movable arms to attach our robots. We planned a program of our robot to stop at the just right distance away so that the arm could pull the cargo handle down. Thanks to the gravity, the cargo will fall out of the plane when the door is open.
As you can see, lots of analytical thinking and knowledge about math, physics, construction, engineering, and programming go into this planning phase. I'm so excited to be part of this innovative educational program.
Robot design and construction comes next. Our team's creative designer leads the way. How can we make a robot structurally strong so it will hold together if it crashes? What are moving parts required for a robot to efficiently complete its tasks?
Robotics team members use their growing knowledge about physics such as machines and center of gravity. They are also learning to apply structural engineering principles such as dynamics and the mechanics of materials to design every robot they make.
At last, students get to their favorite step, making a prototype of their best idea. There are hundreds of LEGO Robotics pieces from which to choose. A student material manager helps keep the LEGO kits organized so they can find just the right axle, sensor, or gear.
While one group, our builders, are constructing the robot, our programmers, like me, use Spike software to be sure the robot will do exactly what we want it to do. We read turn right or move an arm or spin. Today, we want our robot to unload cargo and open a bridge. Knowing about programming and how to use computers and tablets really helps me understand what I'm learning in school. Imagine what I will be able to do when I become a real programmer.
Next, we test our prototype to see how efficiently our robot performs its task. We experiment with it. What does it do well? Where is not working properly? We watch our robot closely, analyze how well it achieves our goal.
These students, many of whom are vulnerable, are learning how to make a good choices and evaluate performance skills that help them so much when to choose which house to buy or supervise people in their jobs. I'm Godwin, an ALU intern with this amazing robotics team.
So, our team answers one last big question. How can we improve our robot's performance? Figure it out and then make changes. In the robot design, in the environment in which the robot operates, or in our programming, it takes all of us working together to reach our goal.
As you've seen, robotics looks like it's fun, and it really is. Robotics team members are never ready to leave a meeting.
But they are doing some serious work too, as they gain knowledge and skill that will help them succeed in school and prepare for their futures. Visha and Dennis would like to share their dream with you.
My goal is to become a music therapist who uses technology, just like I'm learning on the robotics team. One of the first robots I've made could dance, which I love to do. I even helped some of our school families make a dancing robot, like you see here.
My dream is to be a cardiologist in Rwanda. So, why am I on the robotics team? Because I know that some of the surgery I do will surely be assisted by computers and robots.
We are so proud of our students and their ever-broadening dreams. Even in preschool and P1, children are fascinated about computers and robots. As teachers, we are eager to share our modern teaching skills and knowledge about how to build teams of curious learners with more African educators and coaches.
Eric Beer-Booz made it possible for Bright School's STELA Future Hopes LEGO Robotics team to be the first LEGO team in Rwanda. Our staff and volunteers have dreams too. Now we are aiming to build the capacities of more volunteer coaches so that students in other primary and secondary schools can join LEGO Robotics teams.
Soon, there will be new LEGO Robotics team in unserved communities in Rwanda and across East Africa. Students will have more opportunities to develop skills that will help them to become engineers, mathematicians, physicists, pilots, doctors, programmers, and leaders in technology. Let us know if your school or organization is ready to host a robotics team.
Thank you for joining us today.
Goodbye from our team at Preschool Muhanga, Rwanda.